What's up, everybody? Welcome back. Today we are looking at building a toy example of an application that uses WebAssembly as like a plugin system. So the idea is, I like the idea of a containerized thing that you can use to extend your application through like maybe user written things. Um, well, I'll give an example. At the last company I worked at, one of the things that we did was like we would look at a we sorry words. The company was a company that used machine learning to identify where objects were in 3D space in a box and then tell a robot to go and like pick that stuff up. So like used for like manufacturing, right? You have like a bunch of screws in a box and you want to go put the screws over here in these like holes, so the robot needs to know where the screws are. And one of the things that we did at that company was once we found all of the objects in the bin, you have to know, okay, which one is the best one to pick up. And like the heuristics for which thing was best was different for every customer. And so we would have to make this like super like intricate part selection algorithm that like worked for everybody, but was like customizable for different scenarios. And I always thought, man, it would be cool if we could write custom part selection algorithms and inject them at runtime and like use one per user, whatever, right? If we had like super custom behavior that you wanted for one box, then you could do that. And you know, I've seen like the concept before of like embedding like a Lua engine in your like game and then using Lua scripting to manipulate the world in some way. But I always thought that like if I were to try to do that in my own application, I wouldn't really understand like the implications of what that means for like security and stuff. So the idea of using like WebAssembly for that seems really cool because WebAssembly is like already on the internet and it runs in the browser, and so you know that the containerization has to be like pretty damn good. And it like frees up people to write their like extensions in whatever language that they want, etc., etc., right? So I like the idea, and I've been looking for an excuse to like play with it. And I think I have a project in mind where I think that concept would work. But before kind of like full committing to the idea, I think that I need to understand WebAssembly a little bit better than I do right now. So I think today I want to like experiment with the concept by making like a little toy application where maybe we use like a WebAssembly module to do some sort of like text filtering. And you could maybe stack those filters back to back, right? So you could say like, we'll make one that's like, I'm going to change every A to an E, one that's like, oh, I'm going to like duplicate every letter or something, or duplicate every third letter, right? Like something stupid. But just to like show the idea of let's take a thing that we load at runtime and turn it into something that gets executed on some text, right? That will give me like enough of a feel for, I think it should give me enough of a feel for like the capabilities of WebAssembly and like the sandboxing and like what I need to do to interact with the outside world, stuff like that. So the plan is I want to start by just like creating like a really shitty WebAssembly module by hand because I think that it starts. Obviously, everybody who learns programming, obviously they write assembly before they write C, right? Obviously, that's the way everybody does it. I mean, not actually, but that's what I feel like I want to do to really understand like the basics. Then I need to figure out how to like run this thing. I've like run WebAssembly in a web app before, but it was kind of more like provided to me through Rust's wasm system or whatever. I kind of want to just see like bare bones, what the hell does it do? And then we can go from there. Once we know it works in the browser, then we know it works. We can like build into a desktop app. Figure out how to like interact with the outside world a little bit more. So instead of just doing like, probably our first application will just be like a simple adder or something, and then like maybe we'll want to do something like call into some function provided to us from the outside world that like logs the screen or something. Then I want to like upgrade to compiling to something from Zig, and then we can like work on runtime pluggable text manipulation. That's the plan. Hopefully we rip through this pretty quick and get into like the end stuff, but if we don't, it's no big deal. We'll just continue on another day. That is the plan. Would be cool to be able to inject these wasm extensions into other programs. Yeah, it would be cool. That would, like, if you had some sort of like, I guess like what functions are provided are pretty application specific, but you could maybe consider, there's probably some way to think of like just general math or something. Yeah, I can see that. Okay, so I was Googling around what the hell is wasm, and this Mozilla site seems pretty good. Specifically, like this understanding WebAssembly text format seems like a good place for me to start if we're starting from the bottom up. And it looks like they have basically like some form of like exports that they can do. Let's see if we can find like a more complete example. So it looks like you like make like a WebAssembly module and you like export some stuff from that module. And in this case, they're exporting a function add. And here they talk about a little bit earlier that like the WebAssembly instructions are based off of this like stack machine concept. So I don't know if back in like university, they made me buy this calculator where in order to like add 1 plus 2, you don't type in 1 plus 2. You type in 1, then you type in push, then you type in 2, push, and then you press the plus and it like adds the last two things. I think it was called like reverse Polish notation or something. I don't know why they made us all buy this calculator for like $200. It was like, why make us buy a calculator that does like works in a way that nobody else ever has, but it's like kind of similar to this, right? Where the idea is that like each operation that you can do in WebAssembly, it has like instructions like add and multiply, right? And these things will just work on the last two things that you push to the stack, it seems like. So their like example application here is where I lost it here. They like have a function that they take in 2 parameters and they return 1 parameter, and they just like take these parameters that they had here and they say this function I think says like put that thing onto like the stack, and then they're like put this other thing onto the stack. So there's 2 things on the stack, and then they type add, and then the add instruction will take the 2 last things on the stack, smoosh them together, and now there's 1 thing on the stack. And if I understand correctly, whatever is left on the stack is just returned. So they make a module, they implement an add function, and they export that function. So let's try to build something like this. Let's modify it a little bit to make sure that we like understand, right? Maybe we'll do a subtraction instead of an add, or maybe we'll do a multiplication. Let's get crazy out here, right? But yeah, just like, and then we'll try to load it in the browser and see what happens. So I think it's like, I think this is called WebAssembly text, so what? So we'll just call this like module what. And they're saying that you start with a module, and I think you have to close the brackets. Yeah, so the whole thing's in one big set of brackets, and they can call something like func, like my function. And then I think they take parameters. Somewhere they say in here the format of these things. Somewhere. Function, signature, locals, body. So signature, I guess, is parameters, and then followed by result, like what the return type. Locals are variables, and the body is like the actual work. So we could do something like, let's say that we take in a number. I think it's not $param, it's just param as an i32. Okay, and then let's say that we have like some results. This is also an i32. We'll only take in 1 number for now, and then do the brackets close. The body is within the brackets. Then they're saying that we could do something like, hey, we have some like internal state that we could work with. I don't think we need to go there yet. Maybe we'll do something like we'll just multiply the number by 2. Let's do that. So I think that there's a way to like make constants in this language here. So I think that if we say like i32 const 2, that should take the number 2 and put it onto the stack, if I understand this correctly, which who knows if I do. I don't know. We haven't fucking done this before. And then there's some sort of like multiplication instruction. Oops, I think I searched it earlier. It's just i32 mul. So I should just be able to say, take the parameters, so locals get 0, local get 0. Get the first thing, put it on the stack. So that should be the parameter here, I think. Let's see. Parameters. How did they... So they did it by name. They named the things, but I don't think you have to name them if you don't want to. Yeah, here they just have them like this. So they go by index, I guess. So if I have parameters and locals, I guess the locals just come after the parameters by index, I guess. Okay. Yeah, so I think this should be enough. And then I have to export the function, I think is what I saw somewhere. Export add. So this is export the name by function. So I guess we'll say my func here. And we'll say we're exporting it as my func. And we should be able to build this thing. I think I saw that there's this like WebAssembly binary toolkit, and I was looking at this to say, I had some wasm that I was like decompiling and looking at earlier just to see if I like understood a little bit. But I haven't done this yet. Wat to wasm. So this must be wat to wasm must take in some thing and output some other thing. Okay, so we can take in like wat to wasm module wat output module wasm. Fuck. Expected token found locals get. So what do we do wrong here? Do we need to put all of this in brackets as well? No. We'll look really carefully. It's local get, not locals get. Oh, thank you. Thank you. Much better. Okay. Okay, so we should have some module, and let's like try to get it into the browser in some way. So on this site somewhere, loading and running assembly code, and we just need to go into JavaScript and do this. So let's do like index HTML. He's gonna be doc type in all capitals HTML. I don't remember. Then everything gets wrapped in HTML, I think. And then I think you have like head, body. I'm so rusty. And then I like stick it in a div and I say like, hello world. Let's just make sure that this like loads. Firefox index HTML. Okay, does that like open something? Hello world. Okay, we're chilling. So here we want to do like script is something. Source is like index.js or something. And then we edit index.js. Thank you. I did misspell the back div. And yes, the browser is fucking annoying because it has to support everyone's broken shit. And so it just allows all sorts of garbage. But I wish it didn't. Okay, so in here, we can call some sort of like console log hello world in here. Let's just make sure that this gets run as well. So here we go back to browser. We open this, we refresh, and we look at the console. Cool. So we have some JavaScript running. And then somewhere in here, we should just be able to fetch some WebAssembly module and then do something with the module. Okay. Okay. So what happens if I just copy paste this here? Surely this isn't going to be right, but let's just start here and figure it out. What do they have in their import object? What the fuck is import object? What the fuck is instantiate streaming? We get like the module here, a response object or promise that will like get the bytes, and an optional import object containing the values to be imported into the newly created instance, such as functions or WebAssembly memory objects, blah, blah, blah. So we don't need anything right now, I guess, probably. So I guess we just leave it empty. It's optional arguments, we just don't pass it, I guess. And then can we do like console log results? Does this work if we're not in like an async function? I think it does, because we just chain the promise here. I think that's fine. I think it's fine. Let's see. Let's see. Refresh. Oh, fuck this shit. I forgot about this. Oh! Okay, so, for some reason, I don't know why, Firefox doesn't let you load wasm from the file system. So, like, for some reason, just, like, using files as, like, using file URLs is just, like, not safe for some fucking reason. I don't know why. But it just means that we have to run this through, like, an HTTP server, which is annoying, but we can make that work. We already had Python in the environment, so we're chilling. You can run a local server with Python 3. Yeah. That's exactly what I was about to do. You beat me to it. But I wish I understood why. Why can't the wasm file URL? Like, why? Is somebody going to give us an answer? Dude, that's so funny. What the fuck? But, like, why? Why does it not work? Okay, I don't care enough. This is probably what I did last time, was I searched, like, for, like, 3 seconds and then gave up. That happens all the fucking time. Okay. So we have our server, and we should be able to go like localhost. What port is this? 8,000. And for some reason the font is fucking different. That's weird. Okay, so type error. Response has unsupported MIME type text HTML expected application wasm. So we did something fucking stupid. Test.wasm file not found. Okay. Are we stupid? Module wasm is what we called it. That's what we called it. That's why. Okay. Let's see. Module. And I guess we just refresh. Okay. So we have a WebAssembly module who has some exports. MyFunc. Nice. Okay, so how do we like use this thing? How do we use this thing? It looks like they just say call the function. So we should just be able to say console log results instance exports myfunc2. Yeah, sure. So we got 4, cool, which indicates that our idea of multiplying the thing input by 2 sure is working. If we punch in 4, we should get 8. 8, chilling. And let's just double check that we understand this a little bit. Let's do something like, let's try to do like some sort of like accumulator. So maybe we'll do like I32 and we'll say multiply this number. Maybe we'll call this like pow. And we'll take in some parameter and we're going to take it to the power of some other parameter. So we're going to have to store the accumulation in some local, which I think you can name with accumulator. We can name this pow, and we'll call this base, or I guess we'll have to call this exp. And we don't have any like control flow. So how do we like loop in this language? Would probably be in the understanding the text format. So somewhere they're going to tell us hopefully how to loop. There's so much like garbage on this page. Okay. Memory. I don't really care about memory. I want like control flow. There's call, so we could do it recursively, but I don't want to do that. I want to jump. There must just be some sort of like jump instruction. Surely. Don't call me Shirley. So fucking stupid. Shared memories. Okay. WebAssembly loop. Surely somebody knows what I'm asking for. Here we go. Loop my loop. Perfect. Okay. So if we want to like we want to do a to the power of b, we make some loop. And brif is the thing in here. So this is probably branch if. So they're saying if they have like some condition, which is this thing here. Yes. Okay. Got it. So they're saying, hey, if this was true, we go back to my loop. Otherwise, we break out, I guess. Or maybe this is break if. I spelled Shirley incorrect. I haven't spelled Shirley correct in fucking years now. I don't care if people get it or laugh. I chuckle every time. It's like, it's one of those things where I don't think the joke is actually funny, but saying the joke like you think it's funny is kind of funny in my head. Like, there's like a level of irony that like you need, or else you're just lame. But you're still lame, but you're tricking yourself into thinking that you're not. Okay, so what I don't really understand is why are they calling it a loop at all? Right? Like, if this is just branch to some label, like why aren't they calling it label like you would in like with a goto in C? Probably because they just don't have arbitrary gotos. Branches to a loop or block. Block creates a label that can be branched out of with a BR. So BR is branch if. So what's the difference between like a loop and a block? I don't understand. Right, because this is the same shit, right? Branch to the end of the block. Oh, not the beginning. Branched out of. I see. So this is the opposite of what I would have thought. But okay, that makes sense. So loops are like backwards branches, blocks are like forward branches, I guess. Okay, sure. So do we have to name the loop? Do we have to name it? He did name it. What is like the B branch if instruction? Does it require us to give it a parameter? BR branch the loop. Most of the time you'll want to put this in an if statement and only branch on a condition. Otherwise, you may have an infinite loop. BR if. Yeah, okay. It does seem like you just have to pass it. Is there like a more official reference? WebAssembly instructions. Where do these guys come from? WebAssembly instruction. Fuck. We're back where we started. Like, I just don't understand. Like, it seems like surely you must give it a location to jump to. I just was surprised. It doesn't seem like they have like an explicit like grammar here, you know? But from the examples, you can figure it out for sure. Thank you, Wacky. This does look more like an official grammar, hey? Instructions. Branch. Oh, BRF. Oh, it's just not fucking searchable, but it's right here. So it does look like you need the label. Okay. That makes sense. Okay. So that means that we need to name this thing for sure. And so we'll just call this L because I don't want to fucking name it. BR if we go back to L, and we were probably going to branch if true. So we have some sort of like exit condition. So we're going to look at like local get to 1 exp. So what I think I'm going to do is I'm going to like basically decrement exponent every iteration of the loop, and when it's 0, we can break out. So we can say I32 const 1, right? So we're going to take the exponent, we take 1, we put that on the stack, and then we do I32.sub, and then we branch if this is less than 0. So we have to compare this in some way. I don't know which direction sub is going to go, so we should figure that out. I assume that it's the second thing minus the first, like the 2 things back minus 1 thing back, but it might not be. Melo, thanks for the prime, or tier 1. Thank you. It's funny, in my brain, I just assume prime because that's what I would do. And everybody always does what I would do because everyone is just like me. I know, part of me does actually think that though, and I have to remind myself, wait a second, no, that's not true. Other people have other thoughts. That's crazy. Okay, where's subtraction? Here we go. So 10 minus 3 is... Top item on the stack will now be 7. 10 minus 3, yeah, okay. Okay, so we take this thing and we minus 1, and then if... How does, like, comparisons work? How do comparisons work? We must have to, like, make some sort of less or equal, greater or equal. So if this thing is greater than 0, then we jump. So we use greater than. So we say GT underscore U for probably greater score. Oh, signed and unsigned. Okay. So we say I32 GT S. If it's greater than 0, signed, then we jump back to the beginning of the loop. Yeah, okay. And then all we have to do is actually do some work now. So here we're going to say we have our accumulator. So before our loop, we're going to take the initial parameter. Yeah, local get base, and then local set accumulator. So we like put the thing in the thing. But I guess we actually don't need the accumulator because we can just use base as the accumulator. No, because we need to multiply by base every time. Okay, so we take base, we put it in the accumulator. Then every iteration of the loop, we say, could we get the accumulator? Could we get the base? And then could we multiply those things together? Then this multiplier thing is on the stack, so we need to put that back into the accumulator. Yes. Aren't the comparisons also for 2 arguments? Don't you just have x minus 1? No? Yes, because we didn't save exponent. You are right. You are right. After this, we have to save the exponent. But how do I save the I guess I say local... Do I just do local set exp? And then local get exp to, like, get it back? So that I have something to compare? Or is there, like, a stack... Is there, like, a stack clone method or something? Memory instructions... Copy. Fill. Load from memory. No, it's not really about memory. It's more about, like, stack. Variable instructions. T local. And keep the value... Yes. Yeah. Haha. This is exactly what I was looking for. It's just called T. Okay, so we have our value here, and we just say local T exp. So now that, like, clones a thing on the stack into the variable, but it's still on the stack, so then we can check our greater than and then branch out. Maybe? Maybe. We'll call this pow, and then we'll call pow. And there's a really good chance we're gonna, like, infinite loop here or something, and then we'll get stuck, and our JavaScript on the page, like, Firefox will go, hey, something's going real slow over here. Did you know that? Do you want to crash the page? And then we'll click yes. I think that's probably what's gonna happen. Okay, so he's mad because expected token result, expected an instruction, unexpected token result. Does result go before locals? Func main, local param, no. Where you need to put the accumulator back onto the stack after the loop. Here I get the stack, the accumulator. Oh, let's see. Oh, like down here before I return. I have to do this because I need to return the accumulator. Good eye, good eye, good eye. Have you guys done this before? You're tracking well. I feel fucking lost. Okay, what is, like, the function syntax? Over here somewhere? This is where we're... yes, they do... param result and stuff. Param result, param result, but I need an example that has both params and locals. I guess we can just, okay, like, if we just do, let's just try swapping them, just to double check. No. Oh, yeah, okay, that's better. So he's expecting 2 I32s, but he only sees 1 I32. Oh, so that's pretty cool. So the WebAssembly, like, assembler is actually keeping track of the elements on the stack, so it's like a compile time error, not a runtime error. That's sick. I was not expecting that. So we need to check if it's greater than 0. But I don't know which way the greater than goes, so we have to go back to the reference and look for greater than. So this checks if 10 is greater than 2. So it's thing greater than 0. Like this. Yeah. Okay. So we have a module that compiled. That's pretty cool. That's exciting stuff. And now we can go back to our little thing here, and we can adjust our index, I guess, to call that function. So index.js, we need to call pow, and we're going to call, like, 2 to the power of 3. Let's see if we get 8. We won't, but what if we did? That'd be cool. This one. Off by 1? 2 to the power of 4 is 16? Are we just off by 1 on the... Oh, hell yeah, dude. Wait, that's sick. Wait, that's sick. So it's probably just that we want a branch if it's greater than 1. Is probably... We probably just, it starts, well, we can just think about it. So it starts at 3, and it's going to go 3 to 2, 2 to 1, 1 to 0. I don't understand. 3 to 2, 2 to 1, 1 to 0. Oh, but it starts by multiplying itself by itself. So one iteration is squared. So that's why. That's why. So we assemble wat to wasm. And then we run the thing. Okay, cool. So now it's giving us, I think, what we expect. Okay. Yeah, so 2 to the power of 3 should give us 8. Boom. Simple. Simple. It's easy, guys. It's so cool. So easy. Okay. Cool. That seems like we understand the language at least a little bit. Maybe let's just try to log, like do one more thing where we like import a function to log to the console or something. And then we'll move on to doing stuff in a desktop app. So if we wanted to call a function that is provided to us externally, how do we do that? How do we do that? I think that would have been importing functions from JavaScript. So we just say, hey, I want to import a thing. Please, sir, if you would be so kind. So I guess just before our function, we say, hey, I want to import this. Why are there two? What is going on here? 2 strings. This makes sense to me. This is like they're giving a type signature. So the function has this like name that we're calling log, and it takes in an i32 parameter. Sure. But then what is this like import double string? Like what the fuck is that? I guess here, memory instructions, maybe? Import? Due to console.log. That's just like a weird, like, wouldn't you just name it something else? I would think, because I assume that you have to like pass in the function. I assume you can't just like use any function in all of JavaScript. wasm import. What? What does import and what mean? Okay. Does someone just like link a reference? Ugh, gross. Give me import. WebAssembly has 2-level namespace. Oh, I could have just read a little bit further, like one sentence after what I copy pasted earlier. That would have given me a clue. 2-level namespace. So the import statement here is saying that we're asking to import the log function from the console module. You can see that it is exported logit function calls the import function using the call. Okay, sure. So when I call WebAssembly instantiate, I must have to pass in. Ah, I see. I see. So here I have, it's because it's like a dictionary that I pass in. So there has to be a key. I can't just pass in a function directly. So it's like I have multiple keys and okay, sure. So we could do something like, here is our import object, and let's name it, our function, and then our function will call console log. Then when we go into our thing here, instead of console log, we'll say, I want our function. And then down here, before we return, can we just like call? How do we call? I actually didn't look at that part. Call function. So it's just parameters on the stack, it looks like. So what order do they go in? I don't know if they go in reverse or forwards order. So we can just check that by saying we take in 2 parameters. Param i32. And then we will just say, we'll log the accumulated thing, but then we'll also say i32 const 4. And then we will call, we'll call the function that we imported, which was log. And then that will consume the stuff on the stack, I assume. And then we can just still return the other thing. Okay. Have to pass import object. Good point. Okay. So let's see what happens. We refresh. Doesn't look like, oh, we didn't assemble. Nothing happened. Nothing happened, which is not good. Why? So we take this console log away. Call this. Like, why is this function not getting called? We give this the import object. We call the function. Our function should be expecting. Oh, did I not save? Function is not log, but function. I think we're importing our function, but naming it log. Are we not? That's what I thought was happening here. That's why I intentionally didn't change that. But I don't understand. Maybe, did I not save? Maybe. That happens sometimes. Oh yeah, he's logging again. Okay, wait, hold on. So here, let's double check this by going to index.js and saying like, we have arg1 and arg2. So let's log those two things together. Refresh, and we have 8.4. Okay, so it looks like that means that the parameters are passed in the order of the function. So if we have like function a, b, we push them in the order of a on the stack first, then b on the stack second. Seems reasonable. Seems reasonable. Just double checking. We change this to 5. Yeah, okay. We see 8.5 there. So we're chilling. We're chilling. Okay. It actually seems pretty straightforward. Yeah, none of that was too crazy. And I can see how you could build complex applications there. I'm a little bit interested in, like, I wonder what happens under the hood, right? When I say, hey, I'm going to push these two numbers to the stack and then call add, I wonder why that must map to 2 register loads and then an add of 2 registers in x86 assembly or x64 assembly, whatever. But I wonder why they decided to do a stack-based system instead of, like, just mapping to registers. I guess maybe that makes it so that, like, no matter what platform you're on, maybe that's an easier way to manage it. You don't have to worry about managing registers from, like, a compiled program point of view. That's up to the runtime, how to determine, like, which things on the stack go to which registers. And then that probably maps cleaner to different architectures. That would be my guess. It's almost like an IR at that point then. That's how that's how I'm viewing it. Because I think that it is, I assume, this could be wrong, I assume that Firefox is compiling the module into x86 and then running that, like, with either, like, a JIT or, like, a little bit of, like, ahead of time. So, like, what I would guess would happen is that Firefox maps some page in memory to writable and executable. He, like, takes the WebAssembly and, like, actually turns it into, like, machine code through some mechanism, shoves it into that page, and then when you call that function, jumps to that page. That's what I would assume. But yeah, maybe not. I don't know. Stacks are also a lot easier than registers when it comes to compiling. I could see that. Yeah, like, just the management. You just don't have to worry about managing registers and stuff. Okay. Let's try calling the same function, but, like, within a program on our desktop, because I think that's where the fun starts. Well, I guess don't starts. I think that I was having fun before that, but maybe it becomes a little wackier, I guess, right? I don't think it's typical. It's more typical to use wasm in the browser. So I was looking up, like, wasm C, right? Like, that's wasm, use wasm from C. How did I end up here? No, wasm C runtime maybe is how I got here. Yeah, here. So I found wasm micro runtime. I also came across wasmer at some point as well. But this guy seemed bigger from when I was Googling. Oh, but it also is, like, more complex. They were talking about, like, when I was looking at this, they were talking about, like, WebAssembly POSIX abstractions and stuff. And I'm like, well, I don't really want a POSIX abstraction. I don't want, like, my WASM module to be able to interact with my disk and stuff. And so I kind of feel like the lower level we get, the less chance I have of not understanding the model of some library. And so this WASM micro runtime kind of seemed like it fit with what I was looking for a little bit better. Also, it's, like, direct, like, usable in C and stuff. So not that WASMer isn't, but this is written in C, which makes me feel like it's going to be easier to integrate with SIG stuff. What happens when you assemble the WASM? Does it basically turn into some elf thingy? My guess would be that it converts it into, like, machine code and just shoves it in memory somewhere. No elf headers, no nothing, just, like, stick it over there and jump there. That would be my guess, but I don't fucking know. I would guess a bytecode interpreter rather than just-in-time compilation, because even pretty innocent instructions may cause hardware traps. That's a good point. Yeah, how do you dodge that? I guess you could, like, you could make signal interrupt handlers though for that, right? Like if you divide by 0, your the CPU will go, whoa, sig trap, don't know what to do. And then if you just had a signal handler for that, you'd be like, oh, okay, I guess we'll just, like, instead of returning normally, we'll just, like, throw an exception or something, right? Like, I think you could maybe handle it that way, but you are right, there's some complexity. The reason that I would guess that that's not the case is because I was working on an application around, like, maybe a year and a half ago. GitHub.com Spheriphoria path planner. Let's see if there's any screenshots. There are not. But I was taking, like, a map of the city I live in and trying to do, like, path planning on it. So I was using, like, A star to go through, like, basically, like, every single street in my city from, like, one corner of the city to another. And I, like, benchmarked that process using both, like, wasm in the browser and locally on my machine, and they were, like, roughly equivalent, right? So that makes me think that there's no way it could be interpreted. It just wouldn't be fast enough. That would be my guess. But maybe that's wrong. But it feels like you would have to do some sort of ahead of time compilation for that to be at least comparable. Like, it was, like, a little bit slower, but not, like, anything noticeable. Like, like, for a path that was, like, in the realm of, like, 300, 400 milliseconds, it's like, how could you be fast enough? If it's like, how could you be the same? You know? How did you set up non-walkable places? I think I just used whatever. I was just using whatever OpenStreetMap gave me. So whatever, whatever lines were there, I was like, you can walk those. Fuck it. Because I think they have tags for, like, things for cars and things for walking and stuff. I never finished as well, so I might have just not dealt with that. Okay, let's build this thing. And I want to use it from Zig. So I wonder if we can do something crazy. Like, do I have Zig right now? I do. Yeah, okay. Let's try to use Zig as our compiler for this thing. So I think we could do cc equals Zig cc. No, this is a CMake project? CMake project. So c build, cc equals Zig cc, cxx equals Zig c++, CMake dot dot. No CMake. Fuck. Exit. MM shell. CMake. Oh, it's a hard life. For us. No. How do you like Nix? I really like I really like the idea of committing my whole operating system into a Git repo. That's, like, an efficient text representation. Like, so just that in and of itself is, like, really great. And some of the other stuff is, like, icing too. The ability to, like, have multiple versions of the same thing installed at the same time is also very cool. I like that. I don't know if I actually end up using that at all, and it might cause more pain than it's worth, right? Like, I don't know. I think that I frequently run into problems where, like, I try to use some Python package and it goes, like, I can't find libstud C++. And then I Google, like, how do you get libstud C++ into my environment? And everyone on, like, online is like, they're so, like, Nix-pilled that they're like, oh, you don't want to do whatever you actually want to do. Make a Nix environment. Like, I don't want to make a Nix environment. I just want to run the fucking program. And so I end up doing, like, cat proc pgrep Firefox maps, and then grep for std C++. And it's like, then I include this path in my LD library path just to, like, run some program, and it's like, I shouldn't have to do that, right? Like, I know that I understand that I'm not doing things the Nix way, but, like, it gets in your way a little bit sometimes. But, like, the Nix OS configuration is, like, so sick that, like, I'm willing to put up with this pain. The idea of having, like, my development environments as Nix shells, I also kind of like. It feels kind of clean. Like, I don't like the idea of using Docker for this, but that's, like, the alternative, it feels like. So, it definitely has some benefits. I don't know if I would... I mean, I haven't moved off, so I must like it enough. That's not a very good answer. But, yeah, it's not available. It's available. CMake dot dot. Make J9. Alright. He's missing something. What doesn't he like there? What is he complaining about? Unknown command. Make. Did I spell Zig C++ wrong? Zig CC, Zig C++? Maybe I can't use Zig CC and Zig C++? That would be lame. rm-r star, rm-rf star, dangerous command. Let's just try compiling it with normal GCC, I guess. Could be that they're using some sort of like GCC specific shit. That's fine. I don't really know. I was a little worried about like interop between GCC and Clang compiled libraries, but I think it's with C you don't have to worry about that. That's more like a C++ problem, I think. I hope. Okay. How do I like use this thing? Samples? Demo, examples, samples. wasm C API. Hello world. Hello. Perfect. This is exactly what I want. So they include wasm C API.h. And then they create an engine, create a store. I don't know what a store is. An engine, I assume, is the thing that runs the wasm. I guess we will maybe, whatever store is will become apparent quickly. So the store is probably where they're like stashing the loaded modules. Okay. So they take the wasm module, they just like dump that shit into memory somewhere, probably. Yeah, so they just f-read this shit into some like wasm data. Then they say, hey, is this like valid wasm? Okay. Then they say, hey, I'd like to make a module, stick it in the wasm store where I can purchase it later. Two-space indenting, instant on star. Yeah, I don't know. Two-space indenting, they used two-space indenting at my last job. And I feel like my gut says that you just get more nesting if you do that. And like I struggled a lot with like aligning stuff. I was like, is this in that if or that if? I struggle with that a lot. But I don't know if like I'm also the opinion that it doesn't fucking matter. I know you're joking about the two-space indenting, but you're right that like it is like you're like, oh. Like that part's not a joke, right? You're joking about the fact that you care that much, but you do care a little bit, right? Or else you wouldn't have said it. I use tab. Dude, my friend uses tabs and then sets the tab width to 3. And I thought he was fucking with me at first. I thought he was just trying to like exacerbate problems. And he's like, no, I just think that's the best tab width. I'm like, that's crazy. I've never heard of anybody else doing that. That's insane. Yeah, tab width 3 is crazy. That's what I said. And I thought he was fucking with me. Or I thought that he was just trying to, like, find problems. But it's just like, no, that's just the way he likes it. Like, that's crazy, man. So how does he, like, run the function? Here they get the exports from the function, and then they call the function. Or they, like, here they, like, cast the function to a function that is runnable. Okay. But then they like delete the module down here without ever calling it? Like, don't they have to call the function somewhere? Oh, they call it down here. So they delete the module before calling the function that's in the module. So I guess the module must be some sort of like intermediate representation that we don't actually need anymore. That's surprising to me. That's quite surprising to me. I wonder if this thing is like maybe they like maybe it's like reference counted. So maybe this kind of like creates a handle to it if we have to delete the function later. No, the function's not deleted. Maybe the function is in the store. So that we create a module, we put the module in the store, and then we delete the module, but the function's still in the store until we free the store or something. Maybe. Interesting. Odd. Okay. But that's not too crazy. Nothing in there is like too crazy. wasm C API. Where is this? Where is this? Include. Find dot dash iname wasm C API.h. That's a weird place for it to be. I guess probably what makes more sense is typically when you run CMake on stuff, you install it somewhere, and it will probably copy the headers that it needs to in that case. So I think you have to do CMake -d CMake install prefix equals install. Just put it somewhere. And I don't know if it lets you I know that in CMake, some things, if you don't reset, like if you don't like rebuild everything, then it won't actually update them. So can we look at this and look for like install prefix? That looks like it applied successfully. So I think if I just do make install now, it'll like make an installer. Ah, yes, perfect. So we have our headers here and our libraries here. Sick. Okay. So let's make a Zig program that instantiates a WebAssembly engine and runs a function that we made. That seems reasonable to me. Make dir source nvim edit source main Zig edit build Zig. Let's make our builds first. So we say pub function build takes in a builder from stud build and returns an error. This is const stud is equal to import stud import. And then we say b add executable somewhere maybe. Yep. And root source file is equal to source main Zig. I like that I've done this enough times now that I actually know what I have to do, which is pretty fun. Wasm test. And I think you have to specify the optimization level in the target as well. I think this won't build if you don't do that. And then you have to say, install this thing that we built, please. Let's see, Zig build. It's interesting that both Google and Clang styles two spaces. And then, yeah, I also find that surprising. This needs to be a build path. Missing target, yeah. So we have to do const target is equal to b standard target options with no care in the world about the defaults. And then this is standard target, this target equal target. Optimize equals optimize. Okay. Zig build. He's gonna get mad about something because I didn't rename this. Standard optimize option. There we go. Okay. File not found, source main.zig. So main.zig. No. Main zig. Save it. And pub function main. He's got to return nothing. And const stud is going to import stud, blah, blah, blah. And stud debug print. Hello, world. Let's make sure that we compile. Everything is hooked up right. Okay. Zig build. Yeah, and Zig out, boom, boom. Okay, hello world, chilling. Okay, so the next, do we need to like get this WASM engine? So, just out of habit now, I always make a c.zig because somewhere in the language reference, they were like, don't put C includes all over the place, put them in one spot so that you only have to invoke LLVM one time. And I'm like, that's pretty reasonable. That's reasonable. So we do it in here, and we say C import. And here we just must C include, what was it? WASM C API? I think. And then in their example, let's just start by making a WASM engine and then seeing how much the program falls over, the build falls over, I guess I should say. So this is an engine is equal to C this, const C is equal to import C zig. Okay. Okay, so this is going to get yelled at us for all sorts of reasons. He's going to go, what the fuck? I don't know how to do that. Unused local constant. That's not what I wanted you to yell at me about. Shut the fuck up. Okay. Get the fuck out of here, engine. Okay, there we go. C import failed. This is what I did want. So he's saying, hey, we don't link against libc, but that's not actually the problem. That's just like a warning for us. The problem is that we have to link system library. WASM? What's maybe? What's in there? What's in there? Lib iwasm and lib vmlib. Let's just link against both. Because I don't want to figure out which is which. Multiple C includes result in incompatible types. Oh, that's also a good reason. That's good to know. Does it not do like... Yeah, I guess it wouldn't even know to do like shape casting and stuff because it would just be like, oh, I have a pointer of a thing and that's not the same pointer. That makes a lot of sense. So putting it in a module, I guess, is a big win there. What is the significance of the dot next to the squiggly braces? So this means like the dot is like infer type, I guess, kind of. If you say like const x is like a struct that has x equals 0 in it or something, I shouldn't reuse the same name, right? This will construct, this will have like x dot y equals 0. If you don't put the dot here, this is like void. So this will not compile because it'll go like, you have a structure here, but you're trying to assign void. What the fuck is wrong with you? So the dot is like kind of like infer, and then you can do things like if you have like an array of like 100 U8s or something. Maybe we'll say 2 U8s so they don't have to type 100 elements. Now you can do something like this where you say like 1, 2, 3. This like, but this is like, give me the reference to this inferred type, which turns into an array kind of thing. You know. Can you do a quick overview of tools used in Linux? I always wanted to develop in Unix, but it's kind of slower for me. I guess, yeah, people do ask for that type of thing. I mean, I don't really do. I'm just like bash and vim, man. I don't know. I think I'm of the opinion that like you just gotta try stuff. I don't know. I'm not a big fan of like copying developer environments because I think that like whatever you end up wanting is like going to be kind of personal to you. I think that there's something to be said about seeing other people's stuff so that you know what's possible, right? The first time I saw somebody use call hierarchy in Eclipse, I was like, holy fuck. That needs to be everywhere. Like like why doesn't every single IDE have that? But like I don't know if I'm not a fan of just like copying someone else's shit, you know? So it makes me like not want to share it. But it's just like it's just Vim, man. It's just NeoVim, language servers, and I use this thing a lot, Ranger, a lot. But other than that, it's not that crazy. Okay, what was I doing? I was linking this stuff, and then surely we have to like add an include directory as well, right? So this is where this is gonna be b path. And this is gonna be wasm micro runtime build install include, and our link path is going to be the same thing but lib. Okay, does that build? Does that build? Hopefully. No. Failed to find dynamic library iWasm. So he searched these paths. Oh, fine. We'll add a link library path, not an include path, because that's where you're fine. If you're gonna search library paths, we'll give you a library path. Fucking whiner, this guy. He's always asking me to do the right thing. Tell him what he has to do, you know? What a whiner. No string.h because libc isn't linked. Yeah, okay, we build. Let's maybe, I do want this stuff to come first, maybe. Yeah. Put a little alarm breaks. Chill in. Chill in. Okay. So we build, and do we run? Zig build, and Zig run. Zig has his own build system? Yeah, it's just built in a language. They just run a build script that calls a bunch of, like, they compile a Zig executable that has, like, a special signature that takes in, like, a standard library build object. It's alright. I'm shocked to see that people seem to think that, like, the build system is Zig's in to, like, other projects, which seems crazy to me. But it's, like, it's not that bad. It's not, like, it's, like, a decent build system, I think. There's something about, writing your build system in the language that you're writing is like a big win, right? Because like you don't have to worry about learning a whole second thing, which is pretty nice. I like that. Okay, so we have our engine. We have an engine, and so let's try to do something with it. So these guys make an engine and a store. So we say const store is something. And presumably this engine can probably... What does this thing do? I assume that this is going to like return null if it fails or something. Can it fail? Who knows? Doesn't look like it. It doesn't say anything about failing, and these guys aren't checking for null, so I guess we'll just assume that it's always good. But we do have to free this thing. So it's probably going to be wasm engine... No autocomplete? Fuck off. My life is so hard. Wasm engine delete engine. And the store delete as well. He builds, so we're chilling. And then what do? They open the file. Why do they fseek here? Maybe just to make sure that they can read the whole file, just like an extra check for some reason. They need the file size, I guess. Because, oh, I see. So they seek to the end of the file to see how long the file is, so that they can know how much space to allocate in this binary thing that they use to upload. Okay, sure. Old way to get file size. Is that not current as well? I've always thought that fseek was the way to do it. Get file size. Let's see. Because I thought that like you could look at metadata, but I thought there's no guarantee that the metadata is right. Yeah, this is what I've always done. Yeah, they don't see. Oh, here they're saying that use stat. But I've always thought that there's no that stat could be wrong. I don't know why I thought that. That might just be like intuition from like working with like file formats and stuff, where like videos will say that they have some length, but they might not actually be that long. So I might just be thinking that when it's just like completely untrue, and maybe stat's like good enough. Okay, but we can use whatever Zig has to offer us. So stood fs current working directory open file module wasm. So we'll say wasm f file is equal to this, and then what does this guy have on him? Does he have a way to like stat? Const wasm file stats is equal to this. Wasm file stats size. Here we go. So then they, in here, create this binary thing. So this is const var binary is equal to this. I guess this is of this type, undefined. And then here, they call this uninitialized thing to binary, and they pass in the file size, which is wasm file stats size data. Okay. Zakbao? No, of course not. Open file requires us to pass in a config object, which I don't give a fuck about. Reading in text mode does not read actual bytes, which is what stat returns. Reading in text mode does not return actual bytes, which is what stat returns. What does that mean? What do you mean actual bytes there? This wasm file, okay, expected this, found that, so... Oh, because our main function can't return errors right now. But now we can if I put a little exclamation point there. And it goes, uh-oh! Okay, we're chilling. And then we have to read this thing into the memory of this binary. Gotcha. So we say wasm file read all into this buffer, which is going to be binary. Why is my autocomplete not working? It's fucking annoying. Fucking annoying. There we go. So we just read this into here, and we say this is from 0 to binary size, I assume. And then we can feed this into wasm file read all here. And then we should be able to validate the module. Say, hey, are you good, bro? Bro, you good? So if this is less than 0, it looks like. Oh, if it's not equal to... If it's equal 0, we error out. Return error, internal error. Boom. Void exclamation mark void means the function can return nothing or an error. Yeah, exactly. If the second argument to fread does not include binary, on some platforms the bytes R and R is read only as N. Oh, fuck off. Yeah, okay. That's crazy. That would be, I mean, I guess I'm surprised I haven't come across that. I guess that makes sense because, so you're saying stat in that case would return too many bytes for what I'm actually reading, which again makes sense because they're doing some transformations in libc that are just like fucking crazy. I don't know why you would do that, to be honest. Like, I guess they're kind of saying, hey, people who are using libc expect new lines, and so we were going to tell them that they got new lines. I just don't like the carriage return thing. It's kind of like no big deal, right? Like, in what scenario is that causing major problems? I guess if you're like hard matching against line endings, but just like, I don't know, the carriage return is just kind of free, I feel like. Stat overcounts, which is at least better than undercounting. I mean, it seems like neither of them are doing the wrong thing, to be honest. Stat is saying, hey, what is the size of this file? And fseek is saying, like, hey, how many bytes will I read from this file? And those are just two different concepts if it's doing weird shit under the hood. The thing that I think is strange is that it's doing shit under the hood. I would never have guessed that fread is going to change what it sees. But is that where, like, LC... Is that what, like, when you type, like, LC C equals all, what does that affect fread? Is that where that gets handled? Anyways, I don't know. Anyways. I'm what do you call it? How do you call it? I'm exposing my lack of familiarity with stuff right now. This has to, we probably have to get rid of this thing. So defer wasm byte vec delete of binary. Do I take in by reference? Yeah, like this. Okay. So read the stuff, we validate it, and let's actually run that and see what happens. Value of view size ignored. Fine. I don't care how many bytes you read. Incompatible types. Bool and comp time int. Oh. Wow, I'm so used to using C libraries that flag their bools as ints that it's a nice little surprise when it's an actual bool. Okay, so nothing... This didn't trigger, so it looks like we probably validated the module successfully. Let's just double check. Smile. He's happy. He's a happy little guy. Because he made it to the end of his program. Nice. Okay. Okay, so we have validated our module. What does the point of setting the name do? What is this for? What is that for? Set name. Cool. No docs in the header. Okay, let's figure out how do we actually like find out what the fuck this program does or this library. Website? Guide? Website. Website. Surely they have docs on the website. User APIs. wasm C APIs. Okay. Set name. No. wasm module. No. Fuck. Can we go to the file list? wasm C API. Module set name. This is so useless, man. Is that really it? Module set name. Like, does nobody in this whole project tell me why I would want to do this? That's super sick, man. It's okay. I'm not mad. I'm not mad. Because they have given me something that I can use that I wouldn't have been able to use without them. So I have to remember that and have to say thank you guys for doing this. But like, why do I set the name? Why do I have to set the name? I'm just not going to set the name. Why would I do it? Well, I don't care what the name is. Are they using like the hello string like anywhere else? When they get the name from the module, but like, who cares? Oh yeah, I'm just not going to do that because it seems useless, and I'm sure at some point I'll discover why it would have been helpful. Okay. So now they say, hey, I am creating some function type. What the fuck? What the fuck? Also, what the fuck is this own? What the fuck is this? Define own. To nothing? Why are they writing own in front of a bunch of shit? What is going on? What is going on? Oh. Oh, wait, that's actually kind of sick. That's clever. So they want to flag pointers to the developer for if they are owned pointers or references to other things. And so they define an own macro that does fucking nothing just so that they can prefix own pointers with own. That's so weird. I've never seen that before, but it makes sense. That's really funny. So you see the word own and you go, they have to free that. Don't fucking forget. Very interesting. I've never seen that before. That's very weird. But kind of cool. I like it, I think. Maybe I don't like it. I think something about it. What is wasm func type new? What is this? Wasm func type new 0. Like, I guess this creates a pointer to something that takes in 0 arguments and returns 0 things, I guess. Like, these, like, this 2, 0 has 2 argument types passed in, and, like, I assume that 0, 1 has an arg-r for return type. So if our function, pow, from back in the, back from an hour ago, if we have memories that are that long, he takes in 2 parameters and returns 1 thing. So we have to make something that's like, wasm func is going to be wasm func type new 2, 1. Yes. Adding a global override on 3-letter lowercase identifiers seems real sus. Just prefix the variable names with own. Yeah, you know what? Now that you say that, that's also crazy. Because that means if you just write own in the middle of any variable name or any function name, it just gets, like, stripped the fuck out. Okay, I take it back. I actually really don't like it now. That's real, but it's still funny. It's still funny. Okay, so here, they don't have an example here, I guess, of populating these things, but we can probably figure it out. So they're asking for val type pointers and return type pointers. So that means that when we were in the C API header, oh, here we go. Here's like a little reference of a markdown file. Let's read this. This is really short. The developer can learn these APIs at wasm.h. Okay. That's fine. We'll just go back to wasm c API h. Or you could just use comments. We don't do comments here. Yeah. How do we create like a wasm val? New 0. New 2, 1. So this is going to take a wasm val type p. Where am I? I feel like I'm not where I want to be. I want to be here. No, I want to be... What the fuck? Oh yeah, here's where I was. Yeah, this is the file I want. So new 2, 1. So it takes in val types, and then somewhere in here, I saw here we can create val types with const f32. Like, what is value type construction shorthands? So can I share these? between multiple instances? Like, is the val type, what is this thing? Like, this doesn't have any state associated with it, right? Like, this is just, surely, like, what is this thing? Wasm val times yeah, so this is just a uint8. Why the fuck would I ever do this? Right? Like, is this not just an enum tag here? I mean, surely there must be something else going on there. Where would this be defined? This is gonna be called like star wasm val type new. Where's it defined? Wasm val type new. Here. So what does he do? He mallocs a thing. Oh, and then he sets the kind here. Val type is a wasm val type t. But didn't they define it as a u8? Am I high? I could have sworn I saw a wasm val type t defined as a u8 in the header. Oh, it was val kind, not val type. Oopsies, oopies. Okay, sure. So this thing has some state associated with it, but like, what is in it? Wasm val type new. Wasm val type. Like, where is this thing defined? What is in it? You know? What is in it? Because like I want to know if I need to make a new one for every single function that I bind, which doesn't seem clear to me at all. Is it related to video editor? No, unfortunately, or not. Maybe not unfortunately. But the video editor project is done for the time being because I tried using it and I was like, I don't like anything that I make with this. Not because the editor was bad, but because I didn't like the idea of cutting down my shit anymore. So I just stopped. So it's over for now. But maybe at some point I'll decide that I want to go back. Wasm C API internal.h43. You found it. Okay. So there's no weeks of work down the drain? No. It's not down the drain. It was fun. The process was fun. So this thing, it looks like we don't need to, like, it seems like we can just allocate it once. No big project right now. I think that probably if this goes well today, I have an idea for a project. I just don't want to talk about it until I'm a little more confident that it's going to work. So I have an idea for a wasm plugin based project. I just want to get through this first. Okay. I guess we will just say that we have F32 wasm I32 is equal to C wasm val type new, and this is a C wasm val kind t of just wasm I32, I guess. So then we take in two wasm I32s, and we return a wasm I32, if I remember correctly. Module what? Are you gonna keep going with the terminal emulator at some point? Yeah, why did I stop? I think I just got bored. It does seem like, I think that I've decided that it was kind of past the point of being interesting. Like, what ended up happening with the terminal emulator project was it was just a lot of like, oh, today we're implementing this API, and the API would just be like, go backwards. And you'd be like, okay, we go backwards today. And then the next one would be like, okay, today we have to do go forwards. And it was just like, stopped being interesting and became more like slog, was kind of how I felt about it. So that's why I stopped. So I don't know if we'll go back. But I mean, it's not off the table. Not off the table. Okay. Okay. So this guy is going to take in i32, return i32. So this is just wasm i32 for all three, right? Is that what this is supposed to be? I can't remember. Wasm func type takes in optional pointers to arguments and return type. Okay, yeah. Sure. And then what do? Then they have some sort of function, and they create... Whoa. So here they have the type of the function. So this is the wasm func type. Okay. And then here, what is like hello callback? A function to be called from wasm code. Oh, I'm mental. This stuff doesn't fucking matter. This is if we are giving a function to wasm, but we already have the function, so we don't care about it. We just want to take in the one that exists. Oh, wait, no, we do need to do that because we called log from here. So our log function just takes in two i32s and returns nothing. So let's do that. We'll do this guy is the log func type. He takes in the two i32s, and then our version of this is going to be pub function, pub export function, export pub function, pub export function, export function, function. I think it's just function. We got there. So we'll call this like wasm log callback, takes in A i32 and B i32, and he says, hey, could we use the C calling convention for this? And here we'll just say std debug print a number. Okay. So that's what this is for. And so we have 2.0 log func type, blah, 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 and then we can create the callback. So that's this. Classic last 10% is 90% of the work. And what's kind of fun is that because for streaming, it doesn't actually matter if I make anything because the product is the video, not like, which is kind of weird, like not the actual thing. The video is what's being produced. I just never have to do the boring part. Isn't that kind of fun? Mix of snake case and camel case is breaking my head. Well, camel case is like Zig functions. Snake case is Zig variables. And then this external module is just using snake case, so we don't really have a choice there. Yeah. Here we have to defer C wasm func wasm val type delete. I really don't understand this part. I'm gonna have to look at this after stream and understand like why the fuck are they allocating here? Because it seems like such a waste. Like such a waste, but whatever. Who am I to judge? Okay, so they create this function as externs, and then they create the instance of this guy passing in his imports. So how does he get, like, don't we need to specify, like, the module that he's from, right? We used our function here somewhere. So we need to pass that in, which is maybe what this hello is. Module set name. Our wasm module is we create a new module from the binary. No, because this is the loaded thing. So that's not what this is. How does he name this thing? Imports wasm array vec. So maybe we can look at, maybe next to him he's going to have hello.wat. And he is going to import some function. So he just imports him from the root namespace as hello. How does he name these guys? So here's the store, the module, imports. Imports is what he's feeding in. Okay, so what's wasm instance news API look like? he takes in imports as a wasm extern vec t. Which looks like it has just a size and data of wasm extern t's, which are opaque. So maybe we can look at what is in this thing. What is in this thing? Wasm extern t. That's not helpful. Oh, wasm extern t. I guess I should just set up my fucking C language server. That would make this a lot easier, huh? Let's just do that. Let's do that. Clang tools. That should give us Clang D, and we should be able to jump around a little easier. Check the way they do the callback function in C. You don't get the args directly, you get the vec of the args and the vec of the results, where you put the results if you return anything. Okay, that makes sense. Oh, so then you have any type pointers or something that you have to extract the way you need to, you extract them in some way. Yeah, okay, that makes sense. Makes sense. Okay, so I guess in order to get Clang D working correctly, I think I go into here and I say cmake .-d cmake export compile commands equals on. And then I have a compile commands JSON here. And then if I run in here and I go to wasm c api.h, I think I should see jump to definition working, LSP info, Clang D's running, and if I look for references on this guy, cool. So that looks like it's doing something. And so we can go back to wasm c api.h and look for whatever the fuck we were looking for. I don't remember what it was. We were trying to figure out how the imports work. So it was this wasm instance new creates this wasm declare vec extern star. Oh, Jesus Christ, what's going on here? Vectors. So he is saying, I have some named vector, wasm extern vec t, I see. And in here, I am storing pointers. Okay. Pointers to what? Wasm extern t. Okay, so I'm looking for wasm extern t and seeing what the fuck is this thing? Which is wasm declare ref. Wasm, which is named extern. So wasm ref as extern, wasm extern as ref, wasm ref as extern const. Oof, okay. Yeah, okay. Crazy. So how am I supposed to know what the fuck this thing is? What? I just want to know how to name my thing, man. You know? So what function we're looking at again? It was instance new. New with args. Where does he use the imports? Imports goes into here. Executes the instantiate time linking if provided. Create the C API func import list. Okay, do link. So imports has data. So I have each import is a wasm extern t, which is defined by this weird fucking shit. And he does a wasm extern kind on it. I see. Okay, so how did we make this thing? I forgot already. We called wasm func new. Is that what he did? Wasm func as extern, yes. So he can, oh, I see. So extern is some sort of type erased exported thing. And we, that is cast from wasm func type. And so each of these is just a wasm func t. So can we go look for definition? I forget, do I have a way to search for definition? Telescope, LSP something. LSP definitions. We can look for... Nope, that doesn't work. Fuck off. Okay. Extern as func. Okay, this... Oh my god. There's so many macros. This is awful. Maybe I don't like this library anymore. Wasm func t. Wasm func t. Here we go. Can I jump to this? Oh! Fuck! Oh, so many macros! Oh! Okay. Maybe there's an example somewhere in here. Maybe try wasm time. You said anything for this? I think that there was a reason, but I will look maybe off stream a little bit because this is getting a little rough. But for now, we'll just keep going. We'll keep going. We have to keep going. Samples. wasm C API. Imports? wasm C API. Let's see what examples they have in here. Table.c. Table what? So here he is. Let's look for somebody who's importing. Do any of these guys import from not the global namespace? It does look like every single import here is coming from with like the first thing as zeros. So maybe I just have to, maybe I just don't have a choice. Maybe this guy is saying you can only do it that way. Unless this has another example. But it doesn't seem like I see any wats in here that do it, so. Gross, okay. Unfortunate. It's okay, we'll live. We'll live. So we'll just change our module, wherever the fuck that was. Wherever the fuck that was, where are we? Wasm test. So if we look at module what, we'll just change this to go like this, and we'll name this pow. Pow! No, this is log. That's what we called it. And we can go back to their example and just figure out how the fuck that works. Which was in hello.c examples sample wasm C API. It was this one. So here, their hello callback. Oh, oops. I didn't return the right thing from our version of this. Oopsies. We need to return a C. Oh, we kind of fucked up a lot of stuff here, actually. I just wasn't really reading. So our wasm callback has to take in C, wasm val vec t. Args. And this is a C pointer. Is it star C or C star? Star C. B is results. So wasm val vec t, and then here we say res is this, and then here I guess we need to do like, I'll just do nothing for now. This seems awful. Okay. Okay. So now we can go back here. Where do they set like the name of their callback? Right, like here they are doing wasm module set name hello. But like, is the module not the compiled thing? So like, this is the only place I see that hello linked. But like, this is a weird way to do that, I feel like. Hello callback. This just gets imported as instance new. imports is a vector. Hello func is of hello type with hello callback. Yeah, so I just don't see I don't see the name like anywhere. Like it must be this, but like how? Like I'm missing something. Okay, let's simplify this. We're gonna simplify this because this is taking like too long. We're gonna go back to not calling this function. No imports. Fuck imports. This is too much. Too much. And instead we will just skip imports and only do exports, because that makes more sense to me right now. So they are saying, hey, I've like constructed this wasm thing, and I would like to get the exports. Oh, so here we need to construct our instance. Okay. Const instance is equal to c wasm instance new. Here we can pass in null because we have nothing. This is null, and then everything else is fine. Then we can check if instance is equal to null. We have a problem. Okay. He doesn't like this. Where's module? Why don't we have a module? Wasm module new. Did we not make one? We did. Wasm module validate. Oh, but we didn't actually... Oh, this compiles it here. I see. So we have to make a new module here. Const module is equal to c wasm module new. Then we use this thing for chilling. If the module is equal to null, we have a problem. We create an instance from the module, which I don't understand right now. Do not understand, but that's okay. Okay. And then we should be able to look at its exports. But let's see if like what we did just now compiles and runs. Smile. Failed to link our import function. Oh, okay, cool. Wait, this is interesting. Failed to link import function our function. But it's okay, because we disabled that. So we can, for now. So we can just wat to wasm. Try again. Okay, there we go. Interesting. So we're seeing some behavior, which is good. Seeing something happening, which is good. We like it when things happen. And now we should be able to call export. Okay. So we want to extract the exports from this guy. So we say we have const exports is equal to wasm extern vec t undefined. We then extract the exports from this guy. We say, hey, what are they? Which means that this is var probably. And then they just index the first exported function as a function. And then they check the name of the module. Do I not have a way to like extract the name of the function? Like it seems like just pulling data 0 seems crazy to me. They're named. So how do we get the names? Surely, wasm func. Wasm func. Is there like new func type? Param arity, result arity. We have function call. But like, is there no way to like get by name? Like, yeah, I just don't understand. I don't understand. Exports are named, but wasm functions are integer offsets. Yeah, I understand that they have, like, you can access them by integer offsets, but like, should I not be able to pull the offset by name in some way? Multi.wat, here we go. That seems like a good example. Oh no, this is just one function exported. How is this multi? Wasm exports associates a name with the function index. Like, I understand that. But like somebody somewhere has to, like, how is he supposed to associate them back? You know? Okay, so this guy has... Hmm... Okay, maybe we go and look a little closer on our own file system. Samples. C API. Source. So do any of these examples have 2 exports? Check this. I don't know how to get back to that message. Oh, here. Native calls wasm functions and passes parameters. Wasm runtime lookup function. Thank you. Thank you. Big help. Okay, so what is this? This is embedded WAMR guideline from doc. Did I just miss? Like, because when I clicked on this seemed like useless. But this seems good. How did you find this? Thank you. Thank you. Wait, I lost it. I lost it. Look up. Okay. Look up wasm function by its name. Okay, we'll just do this. Thank you. I don't know how I was supposed to find that, but feels good. Feels good. So here we want to say, like, I have our instance, and I would look up how, please. Cool. And then what does this give me? This gives me a... Why is this not compiling? Where's my language server? Is it because I'm in the wrong directory? No, main zig. Okay, I don't know why my language server just like died, but whatever. I was just looking through README links, so I found something useful. Thank you. Big appreciate it. Why does it look like that function doesn't exist? Runtime initialization. What is this? This is just something else. What is WAMR? WAMR is just not what this. Okay. WAMR VM core, which supports WASI and command line interface. Okay, wasm C API. Look up. Yes, that's just not in here. What the fuck is WAMR? Wham bam. WAMR C VM core set of runtime libraries. Oh, this is okay. WAMR is the whole thing. It includes a few parts. Okay. So where did that function come from? So we were in doc embed WAMR MD. This document is about how to embed WAMR into C, C++ host applications. Okay. Are defined under folder core iWasm included. API details are available in the header files. Great. Okay. So what did we install? Ah, wait, okay. Runtime find. I think we're close. We're close. What was the API again? Look up function. Ah, okay. So these guys actually have names, which is kind of nice. So were we just like one level too low? Look up function. This takes a module instance T. Okay. Okay, sure. What else is in here? These have like nice little comments on them. I like this. Okay. Initialize the runtime. Register a module. This seems like higher level. Okay. But maybe this is like... So here I register a module. I wonder if I need to register the module before I look up the function. No, because I just pass in the module instance here. Okay, that's fine. We'll just include this. That's fine. It's fine. It's fine. It seems like the C API is from here and mostly in progress, and they have a wrapper around it. Yeah, maybe I was confused about where to start. Yeah, it does seem like that, huh? But then how did I end up here? I just ran this and I clicked on C API somewhere. But maybe I just should have read more. Okay. Read wasm file into a binary buffer. This does feel more reasonable. So maybe I just accidentally went into their low-level API like a dumbass. Because this seems so much more sane. So much more sane. Wait a second. So here, they just copy everything as 32-bit elements. Oh my god. Wait, this is so much better. This is so much better. Holy shit. Guys, I'm an idiot. Oh my god, all of this is better. We should have just done this. Okay, guys, we're starting over. Fuck what we did. Fuck everything we did. This is way better. Wasm runtime in it. So this comes from whatever header. Okay. Okay. C zig. What was the header we were looking at? It was in wasm export. Thank you. Wow, this is so much better. Fuck everything. I guess not fuck everything. We still want to load this file probably. Okay. Const. Wasm runtime init. This just does some sort of global init. We read the buffer, read binary to buffer. Okay, so what is that? C wasm read wasm. That doesn't exist. Okay, but maybe it's in the other thing, the other header. Lib export. Read, no. Read, no. Read. Wasm, okay. Maybe this is a function that we have to write. Then if we want to export native functions to wasm app, but we don't, then we load our buffer and size into wasm runtime load. So over here, wasm runtime load. Load a wasm module. Oh my god, they're docs. We should have known this from the start, guys. We should have known. Okay, so we just give it a buffer and a size, and then he can output some exception info, but we'll just write null, because we'll say, fuck you. Or, no, yeah. Yes, we will. Okay. Main. Oh, God. We're in the wrong folder again. We're in the wrong folder again. It's a hard life. Okay. Main. And it was... I already forgot. C wasm runtime load. Our wasm file... So we don't need this. We just have... Oh, we did need this. Read all. Okay. This engine and store goes away. We get the file stats. This byte vector goes away. Then we load this thing from... we just need to load this into something. So we just read to end alloc with some allocator. Yes, this makes way more sense. And we say, don't read anything more than a megabyte, I guess. That's fine. Which means we need some allocator. Is stood heap general purpose allocator with an empty config, defer GPA dinit, We ignore the result of this. We get our allocator. Alloc is equal to GPA allocator. Okay. Now we read this thing. We don't need to get the stats. We just say, hey, const wasm data is equal to this. We say, take the wasm data pointer and the wasm data len, and don't give me exception data. I don't give a shit. We'll figure that out later. If we need to, this guy returns the module. Yep. And then we instantiate the module. Oh, this is so much better. So much better. Stack size. 16,000. Heap size. I guess 16384. Heap size. 16384. Error buff. No errors are possible. He might get mad at us for that, but that's okay. Okay, yep. Then how do I use it? Runtime lookup function. From the module inst, I want to look up the POW function. And then can I just call it? Here we say that we have our args is a array of 2 U32s. And we will just make it 2 to the power of 3 to get 8. Then we call C wasm runtime call wasm given our environment. Where does the environment come from? This. Okay. I don't know why we have to specify a stack size here and here, but that's okay. It's fine. And so we call this thing with our exec environment. We pass in our function. And we pass in probably the number of elements. Runtime wasm, what was it? Call function? I can't even find it anymore. Yeah, runtime call wasm. argc and argv. Yeah, so argc is 2 and argv is args. Yeah. And then this is the return value. Probably. Return value stored in argv 0. Okay. So std debug print calculated this args 0. God, I wish I had read a few more docs before starting. If only. Zig build. Okay, this has a bool return, so I'm going to assume that this returns false on failure. Yep. So if this is false, we return error internal error for now. I don't really care about logging for now. Expected U32 found U size at 24. So this is int cast here. Then we expected this. This is at line 31. What's it complaining about here? I thought this was loud. Is it because I have to write this as a slice? There we go. Okay, expected this, found that. So, pointer cast. Is that how I do this? Define discards const. Oh, so this has to be var, which means that maybe I don't even have to pointer cast this. Maybe it'll auto cast itself. And then we say if this failed, return error internal error. Okay. Maybe this will work. Memory address leaked, but we calculated. Fuck, man. Oh! So it worked, and that's why I'm angry. Yeah, that was way faster. Way faster. So that was like all of, like what, like 5 minutes to get that working, right? Okay. do they have like samples? It's crazy that like I just ended up in the wrong example folder. And I don't like, it just feels like when I skim this feels like the such the obvious one to look at. But if I had read this, that would have been very fucking clear. So that's on me. That's on me. Basic seems like where I want to go. So here we have, probably they're compiling things in C to wasm and then loading them in here. Okay. Is there a way for me to, let's try to like do the other way. We need to inject a function. So how do I inject my function back into this thing? That's the last piece of the puzzle. I guess we want to go back to that doc page. That was the most promising thing of everything so far. Embed Whammer. Oh, export native API. Thank you. Thank you. Okay, so we define our thing. And then we register. Oh my lord. Okay. Native symbol. So we say, hey, we have this function foo at this address, and here are my arguments, where I guess this is 2 integers probably. Yeah, I see. So we take some environment. Foo2 is car star, uint star, int. So they have, oh my lord. Breadth first search would have provided better results. Yeah, that's true. That's true. That's crazy. So the function signature. Okay. So this is string. This is buffer address. Okay. Okay. Sure. So that's not too bad. So say we want to provide some function that logs the 2 numbers like we had before. So we have like A is an i32, B is an i32, and we return nothing. We print those 2 things. But now we need to also say that we take in this like env, which is a wasm exec env t. I don't know what this is for, but that's okay. Well, you can find that out later. Now in here, back into our module what, we're gonna say that we require some import. Did we lose the code? We did. That's fine. It's fine. Where that would have been in the like Mozilla MDN wasm import. Loading and running WebAssembly code. It would have been up here when we had the understanding WebAssembly text or something. Yeah, here we go. In here somewhere they had like an import. And we did something like this, where we did this, and we called it like log. That's fine. We take in 2 params. And then down here, we called the function. So we just said call log, and we pushed the parameters onto the stack. So we said local get ack, and then we said the other thing we did was local get or i32 const 4. So we said we're going to log the answer as well as the number 4. And so here we should see the answer and number 4. Then what? Wherever this example thing was here, we define our like native symbols before we, here we just have to register the natives. I see. So we say, after we initialize the entire environment, we say const native symbols is C native symbol, which exists. And this is going to be an array of one of them. And in here, we just paste in whatever the fuck they did, and we just copy paste this thing. So they did here, a native symbol has symbol, all this stuff. So the symbol is going to be log. Signature is going to be 2 integers and return nothing. The attachment is our wasm callback. Oh, this is a func pointer, which is our wasm log callback. And they just didn't assign the other one. They left it as it was. Okay. And then we can call C wasm register natives. Native symbols and 1. I think. Zig build. No field C, so I think this has to be a capital C here. Expected this type found that type, so I think that we can't make it const. So do I have to const cast and pointer cast or something? Const cast? Expected 3 arguments, found 2. Okay, so register natives. What is his third argument? Module name, native symbols, and native symbols. So here they called it env. Oh, okay. So now probably I can come back to having env log here. Right? Right? Oops. I didn't save. That's why. He's mad. Expected that, found that, so we need to just not make it const, I guess. Just a little odd, but it's fine. And then this guy can fail, so we're going to say, if this fails, return error, internal error. Okay. Now let's make our module and zig build and run it. No fucking way. Wait, it actually works. Native callback. Let's go, baby! Let's go! Okay, so whoever read the docs and told me to look at them, you are a fucking godsend. I would have slammed my face into the brick wall for so much longer before figuring this out. So this is sick. It's crazy, like, just so, like, there's a bunch of things, just subtle things that made me make, I shouldn't say made me, I make me make mistakes, right? But, like, when I open this include folder, like, as someone who sucks at reading, right, I see the word wasm-c API, and I'm like, I want to use the wasm-c API, and I see export, I'm like, oh, that shit doesn't matter, it's exports, who cares, right? But it's, like, backwards from what I guess. So and then again, with the examples, I saw C API, I'm like, I want to use the C API, and I didn't read the docs, so that kind of, like, took us down this, like, rabbit hole of, like, bullshit. But this is quite nice. This is quite nice. So, like, my only issue with this was that I just read the wrong header. But this is very easy to use, so happy with that. I was hoping to get to some sort of, like, pluggable text manipulation, but this ended up taking a lot longer than it should have, because I'm an idiot. So I think we're at the 2-hour mark, and I'm going to call it there for today. Yeah, a little unhappy with the progress, but that's okay. Sometimes that happens, and it's fine. Overall, this looks like it'll work. What do we do? We figured out how to, like, write a WASM module by hand, and, like, we got it running in the browser. We got it to, like, call back into things from both JavaScript and C/Zig, whatever. Both, like, two-way interrupt there. So we've got the foundation there. This is actually not too bad at all, so this should be pretty easy to abstract behind something. We'll see how bad it is to actually work with it. I was going to say tomorrow, but it's not tomorrow. On Monday, we'll be back with actually trying to, like, build some sort of system out of this. Yeah. Okay, cool. Thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. It's 4 o'clock now, so for those of you who can't do math, 2 hours ago would be 2 hours ago. So you have to do the math, actually. So 2 o'clock PST is when we start, 2 hours ago to now. So we'll be back on Monday. If you're new, there's a YouTube link in the Twitch description. where we have all the stuff we worked on in the past kind of uploaded into playlists. So things that have may be interesting: operating system, terminal emulator, video editor, QR code decoder, neural network, 3D graphics thing. All of these are around if you want to go check them out. There's a GitHub link in the Twitch description as well, where code for most projects ends up. I don't think I'll upload this in its current state. Probably won't upload it at all because it's not too interesting in terms of like a long-term project. If you're watching on YouTube, there should be a Twitch link in the YouTube description where you can swing by and say hi if you're online between 2 and 4 Pacific. Like, subscribe, Twitch Prime, and okay, let's say bye to YouTube and figure out who to raid on Twitch.